Yes. Okay, this is Jim Darby. He's going to give us a talk on using Java on the Raspberry Pi.
Well, it's actually all boiled down to, there's a bit of a history behind it. I'm actually going to do this talk almost like backwards, which is probably typical for me. I'm very, very short-sighted. Many, many moons ago, my parents bought me a bedside clock. And cost, this is why I wear contact lenses now, but they bought me the bedside clock, and they wanted the clock with the biggest display on it to tell the time. And this I had for about many, many years, and eventually it broke and the radio in it stopped working, but it still had this rather cool display on it. Great, but it was all stuck in the loft. I suddenly thought, after ages, I thought, you know what, I'm going to get that clock and see if I can put a Raspberry Pi inside it just to bring it back to life. I thought, right, okay. Looked at it, it had a white plastic cover, and it had gone a bit, you know, they go like a bit beige, and they go, yeah, exactly. it basically wasn't actually fixable, so I thought, well, okay, right. But lo and behold, the little display thing, pick this up without all going flying and the machine crashing, so it was sad. The display, which is currently showing some garbage, actually still worked. Actually, one of does this
it does.
Superb. Every lecture theatre ought to have one of these, by the way. This is the best idea in the entire universe. So the reason I'm explaining this is it gives you an idea about what the hardware is I'm talking about. Does it work? Can't work. HDMI 3, is it on?
Yeah, I'm just trying to change it to something else at the moment, so a little go back. Try that. Did it work?
Is it on?
No, not now. Just turned it off. I've been having a few technical problems, unfortunately, today.
That's a bit so. It'd be great to actually show it.
It was working earlier, but we sort of. Oh no. Are you plugged into anything?
I'm plugged into HDMI 4. Okay.
Probably breaking the whole thing down.
Is it? The light isn't on. It's not a good sign.
You carry on while
Okay, right. So, I wanted to interface this display to my Raspberry Pi. Fantastic. Turns out it's got a bit of a bizarre interface. Normally the 7-segment display is what they call multiplex. You have to go first segment this, or rather first digit this, second digit this, third digit this, and then repeat. This particular one is actually a bit simpler. They didn't bother all this multiplex nonsense. You just sit there and you tell the display what to do. And if you think about it, it's hours and minutes. The minutes the minutes are actually 2 digits. The hours, what they used to call digit and a half. It was looking at me strange. The reason for that, the units for the hours are a full digit, but the tens of an hour, because it's a 12-hour clock, to save money, they only did the 1, so the 1 is either on or off. Now at this point, it'd be great if I could come and have a look at the end of it, because these are what they call 7-segment displays, which you undergo chalk and talk, so retro teaching. What they call 7-segment displays, I need to do all this so that everything I say later makes sense. Ye old school 7-segment display. These, by the way, are actually known as A, B, C, D, E, F, and G. Just so you might see, I'll refer to those during the talk. That's the A segments, the B segment. So there's actually 7 of them. Fantastic. So we've got. Doesn't matter. So we've got something that can go up to 9. Something that can go up to 9. We've got the little flashy little blippy lights in the middle bit. We've got something else that can go up to 9. What do you call it, I don't know. Yeah, the code in the middle, and you've got something that can go up to 1 at the end. Now these are 7-segment displays. Right, okay, that's 7 times 3, well that's 21 bits to start with. So we start running out of pins on the Pi. So I use these shift registers, comes again in a bit, which these particular ones, which are 959's got the number right, something like that. Which basically do all stuff, but on the left-hand side, you've got 7 outputs. Happy days. 7 outputs go to the 7 segments, easy to join up. Fantastic. Use the spare bits to drive all this, which actually then finally brings us onto the code, now that all makes some hopefully vague sense. So, if we switch the thing on again, work. Right. Yes. Using Emacs to edit it, of course, because that's the editor of Champions.
No, 5. Dear, dear. 5 better.
We're really lucky to still have the same huge font size I was playing around with earlier. Come on, huge font size. Is that almost readable? Is that vaguely readable? Brilliant. Actually, what I'll do is take it full screen. Yes. Great thing about this is it's got lasers in it. Everything's better with lasers, by the way. Although, please refer to my talk, the Jam before last. You can buy lasers on eBay. Like, yes, I'll buy some lasers. Oh, they're really cheap. Yeah, I'll have some of those. Turns out they were actually class 3 lasers. Or to put it a slightly different way, do not look directly into the laser beam with the remaining eye. You can get some dangerously powerful lasers out there on eBay. So, what I'm really genuinely concerned about is younger people getting hold of them, putting, say, the wrong voltage battery on it just to make it even worse, and it might burn out in a second. But in that second, you're going to cause permanent visual damage. And I really don't want that. So be very, very careful of this stuff. Anyway, so here we go at the top. Import is exactly the same as it is for those of you who know Python. But you might notice that these names are a bit weird. Now, Java was written with big systems in mind. So you want to write huge, big, complex systems, and the biggest trouble when you start talking about big systems is keeping track of who's doing what. So, in that particular one, it's import java.time.localtime. It's exactly the same way like Python handles its naming. So that's import from the Java language, time stuff. I particularly want the stuff about the local time. Now these ones all down here, it looks almost like a wrong way around web address, and that's again a deliberate choice. Pi for J is Raspberry Pi for Java, and they did all the bindings to the Raspberry Pi specifically for Java. The reason you do all of that com.pi4j, which is the domain name spelled backwards, if you see what I mean, is so that you know that GPIO factory is the one that came from them. It's not somebody else's GPIO factory. I'm using pi4j.com's GPIO factory. This is really useful in big projects because if something's called something the output or my buffer or whatever, it's like, is it my buffer, is it your buffer, is it his buffer? You know, you can't tell. A bit further down, a bit more Java input-outputty stuff. Right, so when we actually start things off, Java is very strongly object-orientated, which across everything more or less is an object, which is really, really useful. For, again, this is for big systems. So I've got this thing called a class. A class is a group of things you're dealing with. There's only ever going to be one of these, but if I wanted to connect multiple clocks and multiple time zones, this is how you do it. So you could have one clock object for each time zone. You have to connect multiple LED displays up, but you get the gist. You can just bang out, you're in this time zone, you're in that time zone, you can run the whole lot up simultaneously. Which gives us two things. So we've got this class clock, and that extends thread, which is automatically saying that this particular clock class is a thread, it's actually runnable. It can actually do things. You can, so that each of these clock classes, because they're threads, you can go Right, view clock, off you go, view clock, off you go, view clock, and it's just like a sausage machine. You crank the handle, you can turn as many of these out as you want. All of these have a thing called a constructor, which is the same name as the class itself. It's a function with the same name as the class. And the constructor does exactly what it says on it. It actually builds this specific object. Now, if you're having loads of clocks, you'd have more parameters. So what I've put in here is a GPIO controller, which is the one master thing. We'll come to this in a bit. It's one master thing that all the GPIO control comes from. Okay, we sit there and we actually make a copy of that because we're going to use it in the future. And we build the long-term data here. It says STCP is the store clock path. So those shift registers, we're going to shift all the bits in a minute for turning each of the 7 segments, each of the 21 displays, O plus the colon thing, O plus the hours. I haven't got around to doing the AM PM indicator yet, I probably ought to, but you get the gist. What the store thing does is you feed all your data into it, and you go, and display it. Because if you actually shifted all the data in, you'd actually see the whole screen flicker as it shifted round. So you shift it all in and go, bang, show it. You'll quite often see that in quite a few bits of software that's graphical. You'll see it create stuff, then do a go at the end. When it hits the go, it actually displays it. So that's what that pin does. That it's actually STCP is actually the name of the pin on the chip. It's a technical name. I just copied the name from the data sheet. We're then going to use the SPI, serial peripheral interface, to actually throw the data out, because hey, we're going to do it as much hardware as possible. You think about it, we've got the 3 lots of 7 segments, so that's the 21 bits. We've also got 3 bits spare, like hurrah! So I've used the 3 bits spare for our hours, one to control the flashing colon in the middle, and I've got 1 spare at the moment, which I might use an AMP indicator, but generally you look out the window, it's a bit easier. Frankly, if you've lost track of AM and PM, you're beyond my help.
Or you could do a 24-hour clock.
Ah, let's say 24-hour clock, but it hasn't got that top digit. You can't put a 2 in it. You can only do what? You can't even do 0, it's either off or a 1. Yeah, I was thinking about that, I was cursing around.
Yes.
So in here we go, blah, 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 have a byte rate that holds some data, I'll come up with some bit. You'll notice that there's no global variables in this. If you've got a class like the clock here, the thing is, actually I'll explain is, private means this belongs to me, no one else can even see it. So this is data that just this class is holding, no one else can muck with it, guaranteed. And that's useful because that makes your program a bit safer. Final means once it's set, it's set. You're not mucking about with it. So I'm actually being, people say, why do you do all this stuff? So like, that I know, no one else, by accident is what it's typically means, but in big systems things go wrong, you'll get confused. That is enforcing. This is mine, no one else can touch it. Once it's set, you can't modify it. So we now know that that's going to be
A constant, you mean?
Yeah, literally a constant. It's a constant, but you don't know what the value of the constant is until it's actually set there. If that makes sense to people. So you might actually sit there and create a byte array of 3 bytes there. That's quite a complicated way of doing it. I'll come to that in a minute. But that occurs at runtime. But once it's assigned to out, it's assigned to out. It can't change out at that point. Okay. Now something else that's a bit weird, you might think some other things, so that what we've done here is we've created our object. Fantastic. What it's now doing is basically nothing. It's an object, but this whole thread thing up there, all the thread type objects have to have this. Now this is quite interesting. So public void run. Public means other people can see this. I'm actually allowing you to actually call this function. Void means it doesn't return anything. Run means, have a guess what that does, and it doesn't take any parameters. Now if you scroll down a bit more, these little keyboards are so good, they're rubbish to type on, but stuff like this, they're just wonderful. Hey, there we go. For those of you who have, just out of interest, how many people here know Python? Yeah, got a fair share of hands. Try is exactly like try in Python. I'll go through exactly, you get the gist. While true, guess what? Everybody trusts that. Now in here we're having a new set of variables every time around the loop. Once we come into this loop, it's final, it's actually constant, so the time is actually time local time now equals local time dot now, which gives you, it sounds a bit repetitive. Let's say the local time, or the time now, and we're going to store it in this variable called now, and that's not going to be modifiable.
Speaking about time, and my apologies if you've already told me this, but does this imply that the clock has been set beforehand?
Yes, that's why I did that before people would start.
Yeah,
because
I missed that bit.
Yeah, well actually no, I did that earlier on. I actually typed the date, because the Pi doesn't have a real-time clock on it.
Or you could connect it up to the Ethernet.
Yeah. So I actually have it connected up to the internet, which the Pi's do as standard. So it gets the time from the internet and it's accurate. Hurrah! Because I can never remember this rubbish. I'm terrible at it.
You not thought about using a real-time clock module?
Could use a real-time clock module, but
Still
those
have to set it though.
still have to set it, and they drift over time. If you're using network time, I will forget to set it, and the alarm will go off at the wrong time, and it will go wrong. It always does. Which is one of the, if it says something that's completely, utterly wrong, like when I first turned this on, it said it was like 8 in the morning. It's clearly not, so you know it's gone utterly wrong. Now this actually sums up an awful lot of the way, this is how I tend to write software. These are all final. They don't, a lot of them don't need to be as such, but I'm doing it to be absolutely certain. Okay, bit of time now. Hurrah! We're going to take the hour modulo 12. So that gives you the hour 0 to 11, which is great from 1 to 11, but people generally don't refer to, for example, now as being 0:21 in the afternoon. But that modulo thing, so I've then got this hour 12, that's the hour modulo 12, hour 12, obviously, if our modulo 12 equals 0, then it's 12, otherwise it's what it was before. So that makes now not 0:21 PM, but 12:21 PM. Now, of course, if this was a 24-hour clock, you wouldn't be doing that. And we also work out the number of milliseconds as well, because it actually works in nanoseconds, so you have to round up, blah, blah, blah. I'll come to why we want milliseconds in the first place, in a bit, sorry. Look, where's the box? Well, it's gone all over the place now. I'll make sure I take that back. Why is that got a white line? That's slightly distressing. So okay, we've now got this. Now this is just, I need to get rid of that L and M to use red. Undo. Is that it helps I can read the keyboard. Where is the underscore on this keyboard? There. I hope. No, I'm not hitting it quite right. What's this one with a strange beat noise? Slightly wrong.
Left hand side down.
Oh, not twice. In the first shift register I talked about, this is where it gets really down and dirty. This is this array here. The A, the bar on the top, is value 10, the bar on the right, 80, so it gives you the weightings of all the various bits. So that's, well, and it also varies for some strange reason on this display. They have all the 3 digits are actually done differently. This is all fairly, in quotes, fairly straightforward. So when we start building up the data, we're actually going to send our skip. This is just basically binary bit bashing, which is relatively boring. That's creating the bit patterns to turn each individual segment on and off from the values.
How did you work out the bit patterns you need? Is it just a question of randomly chucking?
It was randomly chucking stuff down on the whole of the paper. Yes. The other option is to sit there with a piece of wire and be like, right, that one's come on, that one's come on, that one's come on. Then you sit there and you get to the bit where you actually find they've used a different encoding for each of the 3 digits.
Yes.
And you sit there and you think to yourself, why would you do that? And I still have no clear answer. That's why there's actually multiple tables here for doing stuff. So that's a table for the units of the hour, and the turn on the tens. Oh yeah, and if the 12-hour clock is greater than 9, we set the 1 digit. We set the bit right on the left. So that's just one single bit, so it's on or off. Then go down a bit more. Exactly the same thing. You can see this is now we're actually working out the tens of the minutes modulo 10. You get the general gist. This is actually crunching down the numbers, breaking down the time. So this sets up the tens of minutes. There's our little table that describes the bit patterns we need to do. That's a 0, that's a 1, that's a 2, that's a 3, that's a 4, and so on. So data, blah, 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 blah. So you take the minute, you divide it by 10. I think you don't actually need the modulo 10 on there, that's just really accurate and pedantic on that. A bit further down we want to do the units of the minutes, so we get the minutes, take that modulo 10, bang, bang. Now, this is where the millisecond thing came up I was talking about earlier. If the number of milliseconds is greater than 500, we flash a little colon in the middle. This is really useful because it tells you whether or not your pi's crashed or whether your program's crashed or anything else has gone hideously wrong. And it says in, poke the data down the wires of the shift registers. So we've now got the 3 bytes of data which contain our 7 bits, 7 bits, 7 bits, 1 bit, 1 bit in, frankly, I could go through, there's not a lot of point in this stuff because it's only that display, so we're the only one in the entire world who uses this particular encoding because no one else would be that bonkers. It's really bizarre. So we actually poke the data down the wire, and this point gets those 3 bytes, and the Pi's hardware goes, here's a bit, here's a bit, here's a bit, here's a bit, here's a bit. This is what the SPI interface does. Now, if we just were to put those straight on the display, you can almost like see the whole pattern go. So every half a second, which is how often we're doing this, every half a second it would just like do a weird flicker and come up to the right time. But this one doesn't. What we actually do is we poke the data down the wire. I'm really typing in some rubbish with this keyboard. We poke the data down the wire to the shift registers. Fantastic. This particular thing takes the 2 data buffers. I should also explain about SPI. It's theoretically a very simple interface, but it's used in a very complicated way. If I'm sitting there talking SPI to peripheral, there's a clock signal that basically says and now, and now, and now, and on the command now, it's a swap a single bit. So we've got these 24 bits because it's 3 bytes. So it sends 24 times, it goes swap, 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 swap. Now, there's nothing coming back from that clock module, so I throw the result away. But that's basically what's going on here, and it's done to tell you how many it actually did in case anything goes pear-shaped, which I don't really see how it could. But we just say, if the number done is not equal to how much data we sent, SPI communication failure, only wrote blah. So just to check it sent the whole lot. That was basically for debugging. Wind the buffers back. This is in from the quite complicated Java I/O, so I'm going to skip over. And then, right at the very bottom, we go. And I said that bit about stopping it from flipping. We go and high and low, which is just sort of like, right, turn this, copy it all to the display. Right, I'm going to stop doing that. So that's what those 2 high and low are. This is why we need the millisecond bit. We actually can sit there and say, like, right, okay, this particular thread, this particular process that we're actually running, you want to wait for 500 milliseconds minus how many milliseconds we've done modulo 500. So suppose you actually start up and you actually start running it. It takes a little while for the process to time you, because it might be doing something else. It might be updating the display, it might be flashing the cursor, it might be updating this clock here, it might be updating that. So it's never going to be spot on. So it might come in, you might come in there about 10, I think it was typically when I was printing it out, it was about 5 milliseconds late. But you want to go up to the next half second. So it's 500 milliseconds, like in half a second, minus how far in we were, but because we're only doing half seconds, we do that. And that is almost the entire program. Here, for those of you who know Python, it's the classic, whoa, what went wrong? And finally, right down the bottom, this is the almost pathetically easy or simple main part. This is the bit that actually runs the program. So clock C equals new clock. We get a GPO instance, run. That's it. If I wanted to have multiple interfaces, I could actually start up 3 or 4 of these and say, you run, you run, you run, you run. So, any questions on that? So I've gone to that fairly quickly. Let's get down to the... actually, I'm going to iconise this because it's so tight. So now we need to actually compile and run this. Save. No, don't save it. Save this, but no more. I've never seen these options before. This is cool. Yes, 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 yes. Being fussy up. Right, this is going to look horrible. Can we increase the font size at all? Probably. Let's see. Put 1 space 10 there we go. So what we're doing. 16. Is that readable? Yeah, let's give it that. That's it whinging out various incompatible libraries and stuff. Right, so what Py4J does, now I'm getting to much more specific Python, there's actually a program that comes with Py4J, which is called, strangely enough, Py4J. You then say Py4J, oh, that's what that light means, it's caps lock. No, this is
You have had one of these before, haven't you?
I haven't used it a lot because it's rubbish for typing on, to be honest, right? But it's great for things like this. It's got the laser pointer, I can actually type a few things in and move the cursor and stuff. It's Py4J, not that quote, who's hidden the hyphen on this keyboard? You can see I really haven't used this keyboard a lot, there it is. We can now say compile clock.java, which is that program. Bit of work. Yeah, this is the interesting part. What it actually does is it actually tells you what it does behind the scenes. That's a Java compiler. And do all the G repo through and set this and include all the libraries and blah, 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 blah. So behind the scenes is actually doing all the magic for you. And you can see it took a little while to compile. Now, because what Java does is it creates these things called jar files. Work.
Yes.
Right. Oh, class file, sorry. It's compiled the clock.java into this clock.class, which is the actual class file it's going to use. This is one of the key things about Java that will run on any platform. It's completely device independent, except this one's very device dependent because it actually needs my specific bedside clock that there's no other module for in the entire universe, but we'll skip over that. This, you can see it's also quite a small file, and brilliant, and that gives us the class file at the end. To actually run it, because we like running stuff, there we go, it's Py4J minus R to run it. And it does that. Oh, I need to learn to type. It's just plain clock now, isn't it? Because you can't execute the source code directly. So, what you actually can't see, because it's hidden down here, is, hey, it's now 12:34, a minute before the end of my talk. Ha ha ha! Oh, I got the timing right for once. I got timing right on the talk. And that's the thing, actually running. Now, some people have actually said that the Java has a very undeserved reputation for being inefficient. So this is, because we all like to use our state-of-the-art computers, but I'm being efficient here. This is an original flavour Pi, not overclocked, running at 700 megahertz. I'm not wasting memory. This is a 256 megabyte Pi rather than the 512 megabyte Pi. Single core, of course. Who needs 4 cores? Who needs half a megabyte? 1 gigabyte you're just taking. But if you actually look at this and see how much CPU time it's using, tabs, can we have a new tab? Outside. Oh, what's new tab, someone?
File, new tab.
Oh, of course. It's one of these things you do so automatically until you're trying to do it on the screen in front of you. On the top command, it will show you the massive amount of resources that a particular program is using. Somewhere. There it is. So it's using 1% of the CPU. Okay, it's not just.
It doesn't call it clock.
No, it's actually. Historically speaking, Java C is a Java compiler. Java is a thing that runs a Java program. What it actually does, and you can't see it that clearly from this, is it takes about 2 seconds to start the program, because when you actually run it, it takes that intermediate form, compiles it for your machine, and then goes. If you move machines, it compiles it for that target machine.
Can you use JDK6 and 7?
JDK6, Grandad? I don't know. The original Pies came with JDK7. Somebody help me out?
Never used it on the Pi, so I don't know.
No, I should also explain, this is the very latest, this is actually Java 8. So it's
But
the very, very latest one.
OpenJDK6 and OpenJDK7 are still available for certainly the Ubuntu industry. So.
Actually, I will let people into a guilty secret. That program will only work in Java 8. Because, yeah. The reason being is that it uses that particular thing for doing the time. Getting time right is a real pain. What do you mean by time? What do you mean by local time? What do you mean by time zone difference, blah, blah, blah. I use the Java 8 time libraries because they're better.
Okay.
Okay, I hope that was a bit covered most stuff. If you've got any questions, just catch me after.